Okay, while we're waiting on the evaporust to work for a few days, let's go ahead and take a look at this coil. This is that oddball. It's mounted underneath the chassis, and on top of the chassis just above it, as I mentioned earlier, was the Cornell Electric paper caps. You can see all the leads coming through, and they look like they're attached here to the cap, but I think a lot of them are just attached via wax and have no electrical connection to the coil, because there should just be the 4 leads that you see here with the black, that being the primary and the secondaries. So let's just try to separate these, and there's one off. And there's number 2. And number 3. This one seems odd here. Looks like it may be connected. Nope, there's another one that just came loose. And looks like we've got one more left there. Alright, I think I'll get in here and try to remove some of this off of the coil itself without damaging the back section here of the coil. Let me do that, and then we'll grab the meter here, and let's just check for DC resistance just to make sure the coils are not open. A little tedious, but just a little patience here, and I was able to trim up a lot of the old beeswax here off of the coil. And if you look down here, you'll see all the remains. So it does appear all those leads that were attached to the coil itself, less these 4, were just out of that capacitor bank over here that I shared before. Here's the next coil. It's notated on the schematic as L5. This resides in the oscillator circuit. Let's see what we've got here. Okay, this particular part of the coil itself, you can see the results here showing up on camera. I apologize for the glare, folks. Try to get this positioned. So what, about 146 microhenries and 6.8 ohms. Let's look at the other side of the coil. Alright, here's the other side, close-up view, about 14.41 microhenries and just under 2 ohms, 1.9 ohms. So I'll clean these solder connections up. You can see how dirty they are and how nasty. And I can tell where work had been done at some point in time on the B plus side, where all those filter caps have been placed. Just a real cold solder joint right in this area as well. But I'll remove all the solder from these connections and then retest the coil just to make sure we're good. Okay, this next filter, it's weird too the way this thing was mounted. This is underneath one of the power resistor boards, not this one but the other one, and kind of crammed in right there near the rectifier tube. So seems like an odd location, but you saw how tight the underneath side of the chassis is. This is documented in the schematic. I don't see the DC resistance called out, but if you're looking at the schematic, it shows the coil between these 2 points here in between these 2 points. Again, one being the primary, one being the secondary here, L3 for the second IF. And let me get the meter up here. We can look at the results. So you can see right at 47 microhenries and around 4.15 ohms. Let's check the other side. And here's the other side. You can see around 7.9 millihenries is what it shows, and 60 ohms. So let me notate that. And I think I have one more coil to check before we move on. Okay, here's the last coil before we move along to the output transformer, field coil, voice coil on the speaker itself. But I'm going to leave everything hooked up as is for now. And this last coil is referenced as L4 on the schematic. And I'm reading just under 8 millihenries and about 56.5 ohms. So let me document that. And I think I'll check a couple of these little trimmers just to see how they're set. I would guess they're probably in the, I don't know, 50 to 200 picofarad range, but let's put a meter on one or two of them and just document those results as well. Fairly interesting little trimmers. I don't think I've ever had a radio that had this particular style in it. Or if I have, I just don't recall them. But you can see it's a little bakelite back, and your mica resides here between the two plates. And it has two chassis hole mounting locations. If anybody knows who made these, please chime in the comments. I'd just like to know who the manufacturer was. Be kind of cool to know. Let's hook one up here real quick and just look at the results, see what we've got. Later on I'll probably vary the capacitance, but for now I'm going to leave everything set as is, and then we'll clean them, and then maybe we'll check and see what the range is capacitance wise. So around 121 picofarads or so. Let's look at one more. And here's another one at random, so about 118 picofarads. Let's move along to the speaker now. First thing I did was just hook the LCR meter up here to the thicker leads, and this should be going back to the field coil itself. So let's flip the meter on and see what it shows. So it's reading it as a resistor and about 1.32 ohms. Let me flip this thing over in the manual mode and see if we can read the inductance of the field coil. Okay, in the manual mode you can see I'm reading about 5 henries or so, 5.5. That's the field coil itself, or what I believe to be the field coil. I think I've got the connection points correct. Let me document that as well. Okay, here's the output transformer, and you can see I'm reading about 495 millihenries there, and about 365 ohms. Just a real basic test of the speaker. I'm going to hook up my audio signal generator, and I'm not going to introduce any voltage which would create current across the field coil. And let me just turn this up here and see if we can hear anything out of the speaker itself, which would indicate the voice coil itself is working. Okay, that's about what I would expect to hear without creating an electromagnetic field here by applying some DC voltage here across the field coil. But we can cheat real quick. Let me just grab a small magnet and place it here, and let's see if the amplitude increases. And you can see the amplitude did increase. So I think the voice coil is performing as well. Everything looks to be in fairly good shape on this speaker. Okay, folks, I appreciate you watching. My plans were not to check the coils, but since I'm going to have a few days letting the evaporust work just on the chassis itself before I get into some of these other parts, thought I might as well utilize my time effectively. Thanks again for watching.